nice to meet you to this new episode of Wickbit. Here we have the Yamaha RX-E810 amplifier and radio and stuff like this, receiver I think. And we would like to have a watch on it, what's happened with it. Connecting to the power and switching on. Switching on. What is this? I think so. We have nothing to switch on. Yeah, disconnected from the mains. And now I would like to open this. No power. This is interesting. I never have had no power. Yamaha making every time strong power supplies. Don't fail. Cannot fail. It's a Yamaha. Yes. Can that fail? No, not really. It is interesting. We must have the connection. And back side we have also 4 screws. Interesting, why is they doing this in black? Why they are in black on the back side? But it was not open. Interesting. Oh, it was open. Disconnect the power from the main supply and have a watch inside. What could be happened? Look. I must deposition the camera. Interesting, what is this? Here and here and here. Loosey goosey, no. Maybe it's a open thing. Here's the transformer, mains in, and fuse is here, and here is the. It's a switch. Maybe the relay is switching, not switching, because if we turn it on, push here, there is no click. Normally it should be click and then it's on. There is no clicky. No clicky. Interesting. What can that be? A fuse. Could be a fuse. But first what we must check up is the second power supply. This is here. This second power supply makes the standby power supply for the processor, and it should be making a noise. Normally this switching this relay, but in this case nobody is switching. First we must measure. Can see this now. It's complicated to see. It's a little bit, so it's better. So, and then AC voltage. We must switch to volt and AC. Transformers are working with AC. Measure here. 232 volts. Okay, and here we cannot measure, it's nothing open. And what we can do now, nothing. I cannot measure here. The other side maybe. I must check up the plan, the schematic plan, where I can measure. I can measure exact here and the back, but it's too dangerous. If I'm fiddling around and messing around, so I can disconnect this and yeah. This is not good. First I must check up. Maybe the power supply is not running or stuff like this. This is my first thing what I must check up. what I found out in the first measure was here, the Q4. I measure only the diode test. Yeah, I measure it here to here, nothing. Here in the middle, nothing. And here outside, that looks normal. And from here to this place, it's also nothing. That's interesting. This direction was interrupted also. I would like to build that out. And in this case, the Q4, it's maybe also the IC here. We look at the plan. It's not so good. I must check up my soldering iron, switched it on, and cannot build out this board. Don't know why. Cannot build out this board. Maybe we must. I don't know what happened with this today. Cannot pull out. Now it's out. Very strong. I mean, well, the connecting this here and here and here. Strong board. And maybe I can disconnect this here. Aha! Look! Super! But the problem is that I cannot, what is this for IC? This is a TC4013. I think if the Q4 is defect, then these fuses are okay. I measure it. If this Q4 is defect, maybe the IC is also defect. So I must desolder it. First of desoldering, we solder it. Disconnecting from the power. This is very important on power supplies. And also important, if you build out a flat transistor like this, make a photo. The point is that after a while, 10 seconds, you don't remember where it was built in. I'm doing a picture with my mobile. Picture should be sharp. Is sharp. Look. So I know the direction of the transistor where it's built in. Sometimes I make a failure and or cannot remember and so on. This is not so good for that situation. And now we would like to desolder it and disassemble this with the copper line. And here we are. We must desolder it. Okay, and on the other side, I think so will be fit here, so, and then cut off. Look, the rest. We put the transistor out. Oh, it's a little bit hot. So, and now we have the big issue. There is no battery because my battery was over and I put it in the other measurement. So how can it be? We check it up here. No, it's not good. Switch off. I don't have a 9-volt block. Even must deinstall this here. Take it out from here because I cannot go to the supermarket yet to the second. And I have all batteries here, but not this 9-volt. It's so complicated. Wow. Stupid. But we need this. Put it in here, close that and measure. And it's an N mode. Funny. On the plan it's a NPN transistor, and now it's an NMOS. How could it be? That could be. You cannot measure it with a 3 volts because the gate is 5 volt and more. And the transistor is good. What we can gonna do with this? Maybe the IC is defect and no. How we can measure this?
Yeah, the transistor 2SK3850. It's a switching transistor, and interesting is that they said is a MOSFET, and a MOSFET you cannot measure with a normal transistor tester. This is impossible because the measurement in the instrument have only 3 volts or 3.5 volts, and it should be 5 volts or so that the gate is open and so on. Yeah, the thing is that, but in the Japanese, the Q4 is a NPN transistor. I don't know why they do this. Maybe my plan is wrong. it's unbelievable. Or the IC number 3 is wrong, or stuff like this. I don't understand why they're doing things like this. What we're gonna see here is the power supply, and here is the mains. It comes in and going over this rectifier diode to this transistor. And interest-wise, they switch here the transformer with this part. So they switch this here. Here's the return way. The return way, and here comes over this to the transistor, or in the other direction over here, over this diode to the transistor that we checked up. This 2SK3850. It's not a NPN like the plan. It's a MOSFET. The gate will be controlled by this Q1 output from this flip-flop IC. This is a 4000 series. And I would like to check up the power supply here. It comes from here, supplying this over the over this resistor network, and interest over this set diode. I check up this set diode. Then here we have a diode and this capacitor, and here also we have a second diode. It's interesting. This supply this from the VDD to the VSS. This is the ground, and here is the plus supply. The must be the voltage must be here, and that we found out now. We measure it.
Now I must build it in again, and the transistor is not defect. It looks like normal with the measurement instrument. Maybe the IC, the switching IC is defect, and not running or stuff like this. But how we can test this? Soldering iron, where are you? It's interesting. It's also the solder joints are poor. It's like a overheated milk. Looks like. This transistor is not defect, but I thought it was an NPN transistor and it was defect. But it isn't. Okay, that's good. Maybe the solder joints are not good. They're here. Looks like so. Not so good. Here's the transformer, and here's the switching thing. Also this looks also not good. All these connections. Maybe there is only a disconnected thing here. I don't know what's happened with this. So what I found out is that the switching transformer may be interrupted. I disconnect everything. This is the output of the second 30 ohms, 31 ohms, okay. And here input, nothing. But my measurement. Well, in the measurement we found out that this transformer is defected T1 here and is interrupted here on the primary side. I'm doing now here 10 volts in and it should be correct. 10.2 volts, a little bit more, maybe 1.4 volts more will be required here in this situation. Now we have the I have the idea to find out that this transformer from the secondary power supply is defect, and we measure it. I show you this. I insert now a 10 volt here direct to the rectifier on the secondary side, and what's happened, I can say it's running. Interesting. Yeah. I don't have the connection to the band and so on. I don't have the connection now to the speakers. Maybe the speakers are also wrong, but I think it's only the power supply failure. And what I found out is that I show you this here. Oh, under the sun. The secondary. Oops. The secondary we have a 39 ohms, and the input, it's here and here. It's here and here. Is nothing. Yeah. There is no connection. No connection in between. That means this primary side is defect. There is no input. Look, there is no ohm. That means the primary switcher can switch, but the energy is not in the coil, and so the coil cannot transport it over the magnetic flux and so on, and the second side cannot receive the energy. And this is why it's happened. This machine don't run. Yeah, this is the problem. And I hope so I can order this transformer and get one old stock new one or stuff like this, because the coil is very fine. The windings are very fine, and this is unbelievable to make it by own or by hand. you need a machine for this, or can work days over days and make this coil good or heal it or stuff like this. It's directly interrupted. Yeah, that's happened with this thing. Yes, and well, the transformer was defect. Where is the transformer? Here we have it. The transformer was defect on the primary side and on the Yamaha RX-E810, and so the power supply, the secondary power supply for the master power supply cannot switch on. I'm doing this now with an external power supply, with my regulated power supply, and giving in 10 volts, and that works good. In the service manual is 10.2 volts required. I think so. This 0.2 volt difference is not so, not so much. But interest that this transformer is burnt on the primary side, maybe from switching or from hot, from the temperature in time and so on. Yeah. If you are interested in my channel, please subscribe, and or you can also sponsor me at Patreon. One patron is also sponsored me now. Thank you very much for this. And I say to this video, thank you for watching.